Okay, this is just a quick video that I don't know if it's needed, but I noticed in my other videos that I didn't really talk about naming branches properly. So let's talk a little bit about branch names. All right, and the type of branch names I want to talk about right now are called alkyl branches. All right, alkyl branches. And don't write this little bit down here that I'm going to draw here, but an alkyl branch is basically when you take an alkane, like CH4, right, which is methane, right? This is methane, and we get rid of one of the H's along with its electron, which then allows it to bond to something like a chain, and that changes the methane to a methyl group. All right, and so that's what I want to talk about today, how we can come up with those names. So let's get rid of this and let's define what an alkyl branch is. An alkyl branch is essentially the same as an alkane, but with one H removed. All right, and that allows it to bond to the chain. Technically, it is short one electron, and that's because we remove the hydrogen with its electron, which then allows it to bond to the chain. So, the simplest, a methyl group. A methyl group is CHHH, all right, CHHH, but that's also known as CH3. So notice it doesn't say CH4, but CH3. So next we have an ethyl group, which would be CH2, CH3, or C2H, and instead of it being C2H6, we take one away, C2H5. All right. After that, we can have a propyl group, and again, CH2, CH2, CH3, or C3H. And again, it is not 8, but 7. Now, when it comes to the propyl group, you can see here that this is bonded to the end. Now, you don't need to know this for this course, but there's a different version of the propyl group. We could have the CH3, then just the CH with the branch bonded off of there. And so if the branch is in the middle there, like that, okay, if the branch is in the middle, then we call this isopropyl. Isopropyl. And you may have heard that in something like isopropyl alcohol, which is rubbing alcohol. If we put an OH on this thing here, an OH, you'll learn that that's an alcohol, that's isopropyl alcohol. But we're not worried about that. And you don't have to worry about that isopropyl part. We're just going to call it propyl. All right? So let's do one more here. So let's get back to blue. Let's talk about butyl. All right? And that would be CH2, 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 CH3, and there's 4 from there, or C4H9. All right, and again, you don't have to worry about it for this course, but there are different versions, right? If we put the CH3 there, and then CH, and then now the CH2 and the CH3. So you'll notice instead of it being connected on the end, it's connected on the second one. All right, this is actually called sec-butyl. All right, secondary butyl. That's what that means. All right, and there is one more. Again, you don't have to worry about this, but it's nice to know that it's there. CH3 and C, and then a CH3 there, and then a CH3 there, and now bonded to the middle. So you'll notice we've got now 3 CH3 groups. Again, there's 4 C's in total, 9 H's. This is called a tert butyl. All right, but you don't have to worry about that. This one here is technically called N-butyl. because it's normal. It's a nice long chain. So let's do one more. Let's skip pent, and let's just go right to hexyl to get that point across. And so, again, we're not worried about all the different ways in which it can be done. You can imagine the hexyl can have all kinds of different ways to be branched, but we're just worried about the simple one, C6, and remember it's, to get the H's, it's 2n plus 2, that's for the alkane, so in this case it's 2n plus 1, 12, 13, C6H13, and I'm sure you can probably figure out the rest from there. Okay, so that's a quick little breakdown on how we get alkyl branches. Okay?